Okay, so here's an example of graphing a parabola in standard form and answering all the different questions we have about the characteristics of that parabola or quadratic equation. And hopefully you got this paper off of my classroom site, so you can just fill in the blanks. It's pretty easy. First of all, if we look at this, we know that since this is positive, it's shaped like a U. And this is y equals x squared minus 2x minus 3, or you could also write f of x equals. It's the same thing. F of x and y are the same. This is just a more of a graphing notation. So since it's shaped like a U, it looks like it's opened up, so that's all you write is opened up. You get that right away. Now we have to determine the vertex, and remember this is in standard form. Okay, standard form. So what we're going to do is we're going to find our x value of the vertex first by using our good old formula over here, x equals, and I'll do my work over here, and you should have room to do it all in this. X equals minus b all over 2a. And if we look at this, my a is going to be 1, and my b is negative 2. So a equals 1, and b is negative 2. Okay, we don't need the c until we do the quadratic formula. We'll talk about that later. Okay? So over here, that's minus b would be negative 2 all over 2 times a, and 2 times 1 is 2. So 2 times 1. And that's just going to be negative 2 over, or negative times the negative is positive, so that's just going to be 2 over 2. So that's going to be 1. So my vertex, we know has the value x equals 1. All right? So I'll put that 1 in here, the big red one. And now we have to find the y value of the vertex, and how do we find that? Well, we put that 1 back in the original function, because my function is y equals x squared, so that's something squared, minus 2 times that something minus 3. That comes from up here. Instead of writing an x, I just write a blank, and I put my 1 in here. And y equals, and what's 1 squared? 1, minus 2 minus 3, and y equals minus 5 plus 1 is minus 4. So there's your vertex. 1 minus 4. Okay, so that goes right in here. 1, negative 4. Now you have that. This is your x and this is your y, so the axis of symmetry is real easy. It's just the x value. So x equals 1, that's the formula, and that's a line. Now the maximum or minimum value is just a number. And notice that since this is shaped like a U, we have a minimum. So circle minimum. And our minimum is going to be negative 4, just the y value at the vertex. Okay. Now the y-intercept is when the x is 0, so we just put a 0 in there. And the x-intercepts are where the y is 0. And we might have 2, 1, or no x-intercepts, so we'll talk about that. Okay, so when y is 0, this is easy when it's in standard form, because when it's in standard form, when x is 0, this is xy. So when x is 0, if I put 0 in here, what does y equal? Well, 0 squared minus 2 times 0 is 0, so y equals just negative 3. Or you can just cover up those, and you just have negative 3. So there's your y-intercept, 0, negative 3. Now the x-intercepts are a little bit harder. The x-intercepts, the y is equal to 0. So we could do this over here. Y equals x squared minus 2x minus 3. That's over here. But that's equal to 0. Y is 0. So we can just set this equal to 0 and say x squared minus 2x minus 3 equals 0. And we can factor this. It's a simple trinomial. X and x. And now I look at my signs. My signs are different. These signs are different. The sign of large is negative, so I can write negative, negative, and positive. And they multiply to give 3 and differ by 2, so they'd have to be 2 and, multiply to give 3 and differ by 2, so it'd have to be 3 and 1. So I could put the 3 over here. because the sign of the large is negative, and 1. And I'll just kind of do this up here so we have a little more room. So x minus 3 equals 0, or x plus 1 equals 0. Those are my two possibilities. And that means that x equals 3, or x equals negative 1. All right, so those are the x values of your intercept. And that goes over here. So x can equal 3, or x can equal negative 1. And those are your x-intercepts. So that's what you have to do. So you have to solve this quadratic equation. Now in this case, it was easy to factor. We might have to complete the square. We might have to even use the quadratic formula when we deal with that. So there's all kinds of ways to find the zeros, but they're a little more complicated when it's in standard form. So now we got enough to put our points in. So my vertex is at 1, negative 4. So I go over 1 down 4. There's my vertex. All right. And my y-intercept, that's at 0, negative 3. So 0, negative 3. So there's my y-intercept. Now remember my axis of symmetry, and I should put that in. And I'll try to make that a little bit bigger here. So usually use a dashed line for that. Just go right down to the vertex. Don't go past the vertex. And we know we've got a symmetric point on the other side. So this is my y-intercept, and I know that I have another point that's symmetrical to that, so I'd have another point over here, so I get a free point. Symmetrical points. I'll mark that in blue because that's just a symmetrical point. And we can find the coordinates for both those. And then we also have the x-intercepts, 3, 0, 1, 2, 3, 0, and negative 1, 0. So there's your parabola. And then we connect that with a smooth curve. And I'm going to use pencil just so I can kind of change it if I don't get it quite a smooth curve. I don't want to get any lines. And you can bring it up a little bit past there, and there we go. We don't need any more points. Something like that. And there you go. There's your parabola. Now what's my domain? Well, my domain is always negative infinity to infinity. Now my range, well, what am I going up to? I'm going up to positive infinity here, right? So I know I'm going to have a positive infinity, so the right part of my range will look like this because I'm going up to positive infinity. So I know this part is going to be like this. And then this part will be a bracket, always. And it's just going to be my minimum value, which is y is negative 4, so that goes right there. So you can get that from here. And now you got all your information. Now over here, we just wanted you to write some points so you can see the symmetry. So we'll put the vertex in the middle. So there's the vertex, and my vertex was the point 1, negative 4. And then I can go over here to the right, so this is the point 2. This is my symmetrical point, so this is the point 2, negative 3. And this is the point 3, 0. And that was one of my intercepts. And then over here, this point is the point 0, negative 3, which was my y-intercept, size 0, negative 3. That's a y-intercept. And then this was another x-intercept, negative 1, 0. So these were the x-intercepts. So there's your vertex, your y-intercept, the symmetrical point, and then your x-intercept. So I'll just put those in so we have 5 points. You can see the symmetry. In other words, this is my vertex, and I go, this is, one to the left, one to the right, two to the left, two to the right. Those are your values. You see how they're symmetrical. Okay? So that's pretty much what you have to do to that. And with all the explanations, it took about 10 minutes, so you should try to shoot for 10 minutes on that.